Well, I'll introduce myself so that you can get a moment to catch your breath. Hello everyone, I'm Julie and Pedalino. I build for the brand Pedalino bicycles. And I've been, over the years, been getting into CNC, CAD and CAM as a way to explore different design and ornamental possibilities with my frames, and to kind of get away from handwork and sort of see how the technology, how I can push the technology to expand the ideas that I want to work on with my frames. I'm kind of representing the novice side of things, and Drew, I think, is more of an expert and a master. So I'm really excited actually to share the panel with him, hoping to pick his brain a little bit, but I'll let him introduce himself.
How you doing? I'm Drew Guldalian. I build engine cycles here in Philadelphia. So I mean, I guess from advanced manufacturing ways for me, less artistically and more just kind of trying to push the boundaries of what can be done on an individual scale, which for me was like, I'm very stubborn, I'm very opinionated, and I refused to accept limitations, and that was a big driving force for me to like look at a bicycle and say, I just can't understand why this can't be done, and I originally would pay someone to help me do it, and I'm like very, very good friends with Mark Norstead from Paragon Machine Works, and I would have him make me parts which worked for me to make the bicycles that I wanted to make, but the limitations were in how many parts I had to buy from him and how pigeonholed I was into like, oh, I have 50 more of these things and I'm done with it. Like I want to go to something different. But I spent thousands of dollars on having these 50 parts, and I got to the point where I was like, I have to make these myself so that I can make 20 or 15 or even 5 and keep the bicycles as advanced as I could do it, but on an individual scale. So. There you go. That's I use CNC machines mostly for just, again, the ability to make a part that doesn't exist, less than using it to kind of remove a certain part of work. If anything, I am like quadrupling the amount of work that I have to do because I could buy the dropout or buy the yoke or buy this or buy that, but I'm like, no, I'm going to make it, and I'll make it 1, 2, or 5, or 10. And I went from being able to make like 50 or 60 bikes a year to 20 because I make every single part of the bike. And I'm still only one person. And if I'm making dropouts, I'm not making bikes. And if I'm making yokes, I'm not making bikes. And like literally just spent the last month trying to figure out how to anodize with Jake, and that was cool, but I didn't make any bikes. And I made all the bikes in my booth in the last 2 weeks, which was really hard, but we did it. So there's that, and I'm not sure if we want to do like a open question forum, or if anybody had a certain topic that they wanted to discuss.
I have some questions for you.
Oh, all right.
Okay, so do you come from a mechanical engineering background, or how did you get into this?
Yeah, so from a standpoint of, I went to school for culinary arts and restaurant management, so I have a business degree, and I can cook really fast and pretty efficiently, but I definitely did not go to school for any engineering. I didn't go to school for anything that was relevant to fabricating. But I've always had a pretty incredible ability from a mechanical understanding standpoint. So it was unique for me because I come from a family of people that were always self-employed. My dad's self-employed, my mom self-employed, my grandparents were self-employed. So I grew up in this environment where everybody was kind of like take it on themselves and do it for themselves, and never ever heard complaints or like disdain for their work environment because, well, They created it themselves, and if they had a problem with it, they had to fix it. So when I entered the workforce, I was just like miserable. I was like, this is awful. Like, I hate working for this person. This person doesn't respect anything that you do. And I just like nonchalantly complained to my dad, and he was just like, well, you should just quit. And I'm like, that's the only advice that you like, just quit. So I quit, and I opened a bike shop, and I just kind of like went knee deep into everything about the bicycle. I was 23 years old and just haven't looked back. The only thing I've ever done in my entire adult life is work with bicycles. So I lasted like 6 months cooking, and then I was done with that. And so I embraced it pretty quickly. I was just like, this is what I'm gonna do, and I'm gonna like never quit, because I don't have quit in me. And about 5 years into that, I was like, well, I have a little bit of money, and do I want to invest in this bike shop to kind of like take it to a next level, which would be more employees and more inventory and more headaches. And I was like, or I can sell all the bikes that I own and buy a mill and buy a lathe and buy a bunch of tools and make bikes. And so I did that, and then they sucked. They were junk. I sold really nice bikes to make really crappy bikes, and quickly was like, wow, this is hard, but I'll figure it out. And once I started like understanding the machines, I would say that I had a mentor in the realm of like manual machining. So there's a gentleman, Jamie Swan, I'm sure many people know him, he lives in Long Island. He's kind of like a legend in the Luddite scene of like classic style bicycles. And he's a machinist by trade. And we met, and he just kind of like took me under his wing to make sure that all of my practices when it came to running manual machines was sound, safe, appropriate. You know, don't push the boundaries, always keeping in mind that what you're working on is very capable of hurting you. And as time went on, I just kind of realized that like the manual machines were very effective for how cheap you could get them and how easily they could be set up to make your product quickly and repeatably. But I was like, man, these CNC machines are like, they're amazing. They really, really, really have like limitless abilities. So I bought a CNC machine, and I had no idea how to run it. Didn't even know how to turn it on. And so I now own a CNC machine, and I signed up for a community college course, which was pretty ironic because like I don't know how many people they've had in their course that owned a machine and didn't know how to run it. So I went a little backwards in that department. And about maybe 1 month into that course, like this huge light bulb went off, and I really started to get it. And by the end of that class, which was like a 6 month course, I had already made a batch of road dropouts for my bikes. And like I had this kind of like 1 year goal. I'm like, oh, it'd be really cool if like a year from now I actually made like one thing that came off this machine. And 6 months later I had dropouts, and then like 9 months later I had yokes, and it was pretty quick after that. And that was all mostly because of Mark Norstead. So it was an odd scenario because Paragon Machine Works, who more or less like dominates this industry when it comes to supplying like high quality, very repeatable, very good quality parts. And I bought all my stuff from him, and I had him make a lot of my custom parts, but then I bought this machine, and he was like a huge advocate of it. He was just like, yeah, you should do it. But then I didn't run it, so it was like email after email after email, phone call after phone call after phone call. Like I got to the point where I speak to him like every day, and I felt so bad because he like walked me through the ability to make a product that now I would no longer buy from him. But yeah, he kind of took me under his wing and definitely taught me some awesome skills when it comes to running the CNC machines. That was a pretty long-winded answer.
No, that's really great.
So, anyone else have, like, curiosity's sake? Sure.
I was just curious, for both of you, what advanced manufacturing technologies are you using and how are you using them? So you talked about CNC, there's water jet laser, rapid prototyping. So I'm just curious what you guys use.
I'll let you. I know you use more of the other stuff.
Oh, I mostly use CNC, but I'm very interested in exploring some of the other technologies. I know water jet and laser cutting could be something that would work well for what I'm doing. And 3D printing, I'm very excited about the advances that are being made in that field, especially, you can 3D print titanium and stainless steel, which is what we work in. And I think that's super cool, especially for me, some of the parts I want to make are more sculptural, and so, it's okay for me to do a CAD model of that, and then I'm like, okay, well, how do I actually make this thing? Well, I need to buy a 1-inch by 6-inch by 4-inch chunk of titanium that costs $1,000, and I'm going to machine most of that away. It kind of like, in my mind, it sort of makes sense if that's a 3D printed part instead of a, CNC machine part. But for now, I've just got my little mill and do everything on that. What about you?
I use water jet for just about anything that it makes economical sense for. So the thing you have to realize with water jet is it has a poor finish quality. So if you're, for example, like, I'm going to make plate dropouts, and you make plate dropouts out of water jet, you have an unfinished product. It's not going to hold a tolerance. It's going to have unchamfered edges. It's going to have like these weird like chalky finishes on the outside edge. It's going to have a kerf, so it's going to be at an angle. No matter how high quality that water jet company is, if they have a tilted head, that still is. It's all going to be according to how much you pay. So you're like, well, I want this water jet cut because it's economical. For it to be economical, they need to make it fast. For them to make it fast, it's going to have a kerf. And for it to not have a kerf, it's not going to be economical anymore. You may as well have just made it on a CNC machine.
Interesting.
So I've looked at all kinds of, from here to Sunday, about should I have the dropouts water jet cut to rough size, and then mill all the chamfers, the windows, the tolerances, and this and that. And by the time you pay somebody, so now you have to drop ship your material, you have to saw it, you have to then send it to the water jet company, then you have to have it come back from the water jet company, and you have to trust that the water jet has a locatable section. So it's like, okay, say the dropout is like my mountain bike dropout that has, upside down and right side up triangle pattern on it. Are you going to use like which corner of each pattern are you going to use to locate the dropout to do the further work? And is that a trustworthy location point? Because again, it's water jet, and what you have to bear in mind, the way water jet is done is the material is just sitting on a table. They might put some weights on the corners, something like that. But again, it is not made to hold a tolerance. So
That's plus or minus 10,000.
yeah, well, 10 thou, if you're trying to locate a 12 millimeter dropout that's trying to hold 5 thou,
Yeah.
that's, and all of a sudden, like, your window is 5 thou up here and 10 thou down here, and like, that's gonna drive me crazy. I'm not gonna be able to deal with that. So I only use the water jet to cut my caps out for my chain state dropouts and C state dropouts. So I had get 50 thousandths of an each sheet. They water jet cut all the shapes relevant to being either 60 degrees or 30 degrees for the angled cut for the cap. So those are definitely water jet cut.
Smart.
Plasma, non-existent in the titanium world. Can't use it. So that's not an option. From a 3D printing standpoint, I'm going to be the stubborn guy in the room that says, I don't 3D print, I subtractively print. So all my parts are 3D subtractive printing. I don't do additive printing. So I just don't like it. It's a sintered material. Everybody can tell me that it's just as strong, and it just, for me, the intimacy of making the part has a value, and there's no intimacy. Like, I don't want to order it from somebody when I have the capability of making it, and I do. So I don't print. There's that. Go ahead.
Do you want to answer the question?
Oh, I did.
She did.
Yeah.
Let me see if I can get this right. Okay, for each of you, how much of what you do with the CNC machine tooling is about making your product unique
it doesn't make my bikes any faster. I have 3 hours and 47 minutes of spindle time in one yoke. I have like 2 hours and 10 minutes of spindle time in my dropouts. The only thing that I have that's short is my seat collars, which I can make in 13 minutes in like 8 seconds. So, but that doesn't include the bolts, which have a runtime of 7 minutes each. So that's 2 bolts per seat collar. So, I mean, if I was to add up the spindle time that I have invested in I haven't even started making the bike yet, it makes 0 sense. But I am making a product that is available exactly one place in the world. And to me, that holds a huge value. So I do not make a product that anybody else in this entire universe is making. And there are not a lot of manufacturers and a lot of people that are making bikes that can say that, like, literally, not a single person makes my dropouts, has my bottom bracket, has my head tube, has my seat tube insert, has my seat collar, has my yoke, like, all of it is unique to my bike. So for me, it's about making the bike the absolute best that it can be with 0 compromise. Like, if I was realistic with the world, my bikes would be $20,000, but no one's gonna pay. So, you know, luckily my wife has a good job, and you know, I accept the fact that I'm gonna price my product fair market value as opposed to appropriate, because I put it upon myself to make this product.
So I'm going to answer the question too, but I just want to ask you, what kind of a mill are you running your parts on? I mean, I've got the cheapest, crappiest possible mill, and it requires a lot of babysitting. So my 5-hour dropout program means I'm sitting there babysitting that mill the whole entire time. Can you load a program into your mill and just let it do its thing?
Yeah, well, I have 3 machines. I have one VMC that has like a chip-to-chip time is referred to at 1.8 seconds. It has 25 tools in the carousel, and it has 8 vices. So it has a pallet changer, so I can load material and unload material while the machine is still running. So like when I make the seat collars, again, my seat collars have a run time of just over 13 minutes. The last time I made seat collars, in 2 weeks I made 300 seat collars. So that was literally start to finish. That includes sewing the material, facing the bars for the first op. It's a 4-op part. The tumbling, ironically, is one of the longest steps in the entire thing, because my tumbler can only hold so many parts. And for me to tumble 250 or 300 parts, it took me like 3 days, because I could only do 25 collars in each tumbler. I have 2 tumblers. But from a standpoint of my lathe and my VMC are completely unbabysat. You push go, they run, and you go back. When I make bolts in batches of 100. So when I press the green button, I'm going to come back. There's going to be 100 bolts in the hopper, but each seat collar has 2 bolts. So if I have 300, obviously I need 600 bolts. So it takes a while. It's 7 minutes a run. But the difference is that I press go and I walk away and I do other stuff. I have a 3rd mill that does need babysitting, not from the standpoint of like its lack of ability, but because it doesn't have a tool changer. And so that mill is like the bane of my existence, because every time you think you're going to get a bunch of stuff done, a week is gone, and you're just like, oh, I can't believe that took a week. But what it did was it proofed a program, and it dialed in a program to the point where I'm going to switch it to the other machine, and then I'm never going to have to fuss with it again. So it's very helpful for that. So I don't get rid of the 3rd machine because it allows me to proof a program while still running the other machine. So.
Thank you. So for me, I like it for both reasons, for the individuality and the creation of art aspect and the time savings. Because I sort of come from a weird perspective as an artist, where I'm kind of used to like, okay, if I'm doing a wood block print, I'm going to spend 60 hours carving one block for a series of prints. And if I could get a robot to do that for me, even if that robot still takes 60 hours, that's something that I'm not having to do physically. So when I started building bilaminate frames with the fancy lug work, I did that all by hand with saws, jeweler saw files, that kind of a thing. So we're talking 20, 40 hours into a lug set, which is, you know, a lot of time. So yeah, it takes an hour now for the mill to cut a lug, and I have to watch it. But for me, that's a huge time savings. It's massive, and it's less wear and tear on my body. But I know it's like a weird perspective, like when I talk to other people that are in the industry and they have professional machine shops and they care about machine time and hours on the mill and things like that, they're like, this is a cost prohibitive thing that you're doing. So it's kind of a mixture. I feel very, very lucky and grateful to have access to the tools and technology, because when I'm freed up from what I can physically make with my hands, I have the ability to be much more creative and go ahead and explore those sculptural forms that I just wouldn't physically be able to do otherwise. So I hope that answered the question.
So she can make the bike faster.
Yeah, I can make the bike faster. Yeah.
Less bleeding.
Less
Yeah.
bleeding. I still bleed though. Because always the first blood is like, okay, the bike's being made now. You gotta... Okay, so I always start with, if I'm doing like the bike that I'm showing now, I start with a sketch, drawing, and then I'll bring that into CAD. And I've just recently switched over to using Fusion 360, which is parametric software. I used to do everything in a software program called Rhino 3D, which is great. It's a CAD software, but it doesn't have the parametric capability that Fusion does. So I'll do my whole bike geometry in Fusion now, and then take that back into Rhino and do the ornamental work in Rhino. And then from there, I'll have the model and be able to generate the toolpaths and the programs to run the parts.
I stink at running computers, so we'll just put that out there. I have like zero skill set when it comes to three-dimensional CAD work. What I do have is like this ability to see how I want something to be made, and I have this really awful ability to sketch it onto the napkin and then utilize outside sources to have my parasolid made. So like the amount of parts that I have made start to finish solely by myself are all tools. So like the moment we're talking about any sort of a fancy contour or anything that's like pretty legitimate, I didn't do the three-dimensional CAD work because I accept my limitations. I like consistently try and sit down and get better and better at it. And then I hired Jake, and Jake's like, oh, what program do you use? I'm like, I use Fusion 360. And then in 1 month, I'm watching someone use a computer where I'm like, what the fuck? Like, you just started using this a month ago. I've been using it for 5 years, and I like didn't see that shortcut. I didn't know how to do this. I didn't know that. So I'm like, all right, that's fine, because once the parasolid is handed to me, I'm dialed. Like, I'm very efficient at CAM work. I'm really, really good at making something pretty fast for not being a production environment. You know, I'm very familiar with the material. I'm very familiar with the feed rates and the spindle speeds that I want to run. And I mean, short of running something to the point of breaking an end mill to decide how fast you can actually go, I'm like 1 notch below that. I will have my spindle meter almost pegged. You know, I'm gonna have that thing running at like 80%. I'm not really willing to run it at 100% the whole time, but you know, Mark Norstad in your ear, if it's not at 100%, you're not making money. So I'm very good at setting up, making fixtures, using the CAM, and again, like pretty crude CAD drawings, but I'm not good at three-dimensional. Even my C-collar, which was a part that I kind of started on my own, I got it to like, we'll call it 7 on a scale of 1 to 10, and then I hired somebody to take it to 11 and, you know, utilize that versus whatever I had worked on up to that point, because artistically it wasn't there. And And I use the computer for all the FEA testing also. So all of my parts, I utilize FEA testing, and you know, whether or not it's to decide which part of the material can be removed, or whether or not it's going to say like, you know, this flexes in a way that you want it to flex, doesn't flex in a way you want it to flex. But you know, I think the main difference between the two of us is that she is far more of an artist than I am. I am definitely not an artist. I would, you know, bow to some of the stuff that gets done on that computer because I'm like, yeah, I can't do that. But I will use it to attempt to take the bicycle from being more like, you know, handwork in the form of craftsmanship to being computer work in the form of craftsmanship. Like I try and use the computer as much as possible to make the bike as advanced as possible. So, not sure if that answered your question, but I tried.
Yeah, it sounds like we have sort of we're on the opposite ends where
Yeah,
what I really struggle with is okay, what are the feeds and speeds? How am I going to hold this piece? What tools am I going to use? What are my machining strategies? And I'm to the point where I'm starting to like look for other shops to work with so they can do all that and I can focus on the design. So it's interesting that we're kind of on the polar other ends of that. Any more questions?
Call Mark if he's busy, because he's talking to Drew.
I know, I'm jealous that he has
I
such
went
a
on
tight
vacation with him
relationship.
3 weeks ago. We were riding our bikes for a week straight. But we didn't talk about business.
Yes.
What specific improvements does the Fusion software have above the Rhino software?
It's
Can you repeat the question?
You wanted to know what the difference is between Fusion 360 and Rhino 3D, and for me, it's parametric software. So I can, let's say I'm working on bike geometry. I have a template, and then I open up a table in that software, and I've got every parameter: head tube angle, seat tube angle, effective top tube, reach, you know, saddle height, all of that. I can just plug it in, and then it will update my model for me to those parameters. And if I want to make a little tweak, I just go into that table and it'll change it live on the software. Even if I've got the tubes and everything modeled, it will update that for me. Whereas in Rhino, I can set up that same template, and then once I start to build the actual 3D model around the drawing, if I want to go back and change it, I basically have to redo all that work again. So delete my tubes, do that little change, like make the top tube longer.
What about Grasshopper? Have you tried the Grasshopper plugin?
Yeah, I have, and I honestly, it doesn't make sense to me.
Okay.
I can't think in that way, and like I look at it, I'm like, whoa, this is overwhelming.
The soup of all those.
Yeah, all the little plugins
Yeah.
and the way the logic works and everything is just like, I think you could get it to do what I'm doing in Fusion, but with a lot more work and maybe some sort of a math degree. But for me, it doesn't work out that great.
Thank you.
Yeah.
What are some of the biggest challenges you faced in starting both your practices? How did you overcome those?
Yeah, for me, the biggest barrier to entry is just financial resources. The software isn't cheap. The machinery isn't cheap. Even what I have, I got a mill for $6,000, and that's a lot, and I'm still paying for it. And then you still have to buy a vise or multiple vices, the tooling, tool holders. Every time I break an end mill, I'm like, you know, that's $20, that's $30, and it's just a part of the learning process, but it makes it difficult. And then the materials are expensive, so that's the biggest thing. Like I don't mind learning and taking the time to learn things, but having to worry about the money picture so hard makes it difficult. And I think that a lot of us builders and artists in general could benefit from this technology and do really amazing work with it, but that initial barrier to entry is very steep, I think.
Yeah, no doubt the money aspect. I mean, I'm going to put a huge plug to Paragon Machine Works because I don't think anybody understands what that company is doing for this industry.
Yeah, it's huge.
Because he is offering a product, or they are offering a product to this industry so much cheaper than anyone realizes that is happening. I mean, the money that is invested in the machines in that facility and the money that's invested in the raw materials and the prices that he's selling those products is incredible.
So would you suggest just outsourcing your jobs until you get to the point where you're kind of spending so much time promoting?
I'm all for spending the money, man. I mean,
Yeah.
I just went all in. So I have like, I don't know. I mean, the last machine. I mean, it has eight vices on it. Each vice is $1,000. So it has 2 subplates. I have 114 tools for it. I mean, I just was like, if I'm going to own this thing, I'm going to make it work for me. I'm going to go all in.
Yeah.
And so monetary aspect of it is huge, but you have to be committed. You cannot fathom, like I will say this over and over, I say it to his face, how Joe Rogan, I don't understand how he is so cheap and successfully does what he's doing, because you cannot be cheap when doing this. You have to set aside the limitations that is going to present, because you will get 3/4 of the way through a project, and then what are you going to do? You're going to be like, oh, I need 6 more end mills that are $50 each. I can't afford it. So you're going to be like 75% into a job, and you're going to be like 6 end mills away from getting it done, and you're going to sit on it? No, you got to go all in. You have to have 4 or 5 of every end mill that you use. You can never buy one. If you own one, you're going to snap it, and then you're going to be like, okay, now I'm going to pay $15 in shipping to get one tomorrow because I didn't buy 2 or 3 or 4. And it's just one of those things where you just have to be fully committed from a monetary standpoint of like, this is what I want to do, and it's going to be really expensive, and there's going to be some light at the end of the tunnel depending on what your end goal is. You know, if your end goal is a moving target like mine is, like, I'm never content. I'm always trying to push the envelope. So essentially, I don't feel like I'm ever going to catch up and be at the other end of the scale, you know, where it's like, oh, look at all this money that's coming in compared to how much money I spent. But as long as the bike is getting better, I'm committed. And I mean, I think without a doubt, the money is the biggest hurdle. You know, it's hard. You gotta have space too. Like, I have a huge facility, so that's the other thing. Like, you can have the money, but then all of a sudden you're like, well, this thing weighs 12,000 pounds, and I got to put it on a floor, and it weighs 12,000 pounds. So if this is not you're not putting this down on your garage, because that's like a 4 or 5 inch slab, and it's just going to crack it. So, you know, you got to have a legitimate facility that's going to have at least like an 8-inch slab, and that costs money to have also. So, you know, so I think space is probably the second hardest hurdle, because if you had enough money, you could have enough space. But you can maybe have enough money because you have a small space, and then you need to work within your means. You know, this is why those little Speedios and like robo drills are so popular, because they only weigh like, you know, 4,000 and 5,000 pounds. They're lightning fast, and they fit underneath garage eases. So I find it hard to believe that those companies thought about this, but they literally clear garage doors by like 2 inches. And, you know, there are so many manufacturers that are making small, single part businesses that are doing it out of a garage. And that's why those machines exist. It's called a Speedio. It's like one of the ones where the turret is like a clocked circle. So the way it changes the tool is like the spindle comes up, and the spindle kicks a dog, and the dog disengages the tool, and then the turret like rapid fires down to the next tool, and then the spindle comes back down and pulls the tool with it as it comes back down. It has a chip time of like 0.8 seconds. Like you blink and it's done. So they're really cool, and they're very, very cost effective. You know, they start at like $55,000, and I mean, obviously new, and they're like lightning fast. So
I just wanted to chime in on the cheap side. I've got a Grizzly CNC conversion. So somebody bought a Grizzly manual mill, and then he took and put all the motors on it and got it to connect to the control, which is Mach 3, and like I said, it was $6,000 for that, and it's kind of 4th axis, and I'm able to do a lot with it, like I said, but with babysitting. So I think you don't have to be willing to drop $50,000 just to try this out. There's ways to sort of get around it and get your foot wet and try it, but there's still, I mean, it's still a significant investment just to try it.
Yeah, buy a used machine,
Yeah,
but
there's a lot
you
of
need
things-
to have time on your hands.
Right, yeah.
Because it's gonna need repairs, and
Right.
it's gonna need
Yeah,
you
and-
to take it apart and understand how it works,
The
but.
Grizzly's like that too.
Like,
But-
used machines are like, all three of my machines were bought used, but you know, I just have an ability to assess it and to comprehend, like, this spindle is tight, this is tight, that's tight, this has got not a lot of hours on it, it always cut aluminum, it cut plastic maybe. So it's, you know, you can definitely get into this for a reasonable amount of money, but the irony is that buying the machine is not even close to where the cost ends.
Right.
You know,
It's just
it's
the
like,
big-
other than a benchtop mill, like if you're buying a 4,000 pound machine, you're gonna hire a rigger. You know, so all of a sudden you're $1,500 in on a rigger. Then you get it dropped on your floor and you're like, oh, I need a 60 amp dedicated breaker. And you're like, well, I don't have a 60 amp dedicated breaker. So you're gonna now run a 60 amp dedicated breaker, which is like $400 in cable to go from your breaker to your machine, because you don't wanna be one of these people that puts like 14 gauge wire on your CNC machine. You want it to be 8 gauge wire. So you're gonna run that. Or if you're in a garage, then you have to buy a phase converter, because the machine's gonna be 3-phase and you don't have 3-phase, so you're gonna have to get that. And then you have coolant. Coolant is not cheap. Coolant needs deionized water. Deionized water is not cheap. There's a lot to it. And I mean, and that's where the benchtop mill versus the like proper VMC, there is a separation factor of like what is involved in how much it's gonna cost to get this thing kind of up and running and keep it running. And the benchtop mill, if you're only looking to make, like, Julie is only making one of something and it is a unique thing. And then even the dropouts have like a variation within a concept. You know, the angle for the seat stays might change. It went from a quick release to a 12 millimeter through axle, went from an ISO to a flat mount. So it's like, you know, all these little variations mean that you're making 1 or 2 or 3, even 5 of something is completely capable on a benchtop mill. As long as part of the business plan is not to be prolific.
Right.
Because if being prolific is part of the equation, then that is not involved. You know, it's fine if it's part of the learning curve.
Right.
You know, you're like, get your chops
Just
wet.
get
You're like,
going.
I get it.
Yeah.
Now, the only downfall of that is like Mach 3 is like totally different than running a lot of the other systems. So like you look at Fanuc and you look at Okuma and you look at the Haas and you look at the Siemens and all these other machines. These are all running on a very different platform than the Mach is running on. So like the Mach is running off of a computer, which you have to be very careful of because most computers crash. And you don't want your computer to crash right in the middle of the toolpath because then you're screwed. And where the other machines are running on like really crude, old style computers that's running in the background, but they're very stable. And they also have a lot of like every brand has a very unique this or unique that. So like a lot of times you'll get efficient at Mach, which is cool because you can go like one step up and go to like a Tormach, which is also running on a Mach controller.
Yep.
But then the moment you go to a more legitimate machine, you're gonna have a whole nother learning curve involved. Because no, Tormach, yeah, I mean, I think there's a couple, like Shoreline, I think that they use the Mach. I mean, like,
I would look at, if I was looking at a Tormach, I'd honestly spend the extra and get a
Get a used
Haas.
machine.
Get a, yeah, a mini mill or a,
Grizzly CNC
or,
spend money on it.
yeah.
yeah.
That's what yeah.
Tormach's like 12
Tormach,
grand now, right?
Yeah, they just came up with a newer model that's
Yeah.
like 20, 25, and it's like, I'm just gonna get a Haas mini mill at that point, you know, just a little bit better.
I'll sell you one.
Really? Let's talk. Ooh.
So, any other
Any other
questions?
questions? Yeah.
For someone who's never done any CNC before, any what's a good way to get into to start your process?
Take a class.
Yeah.
Is that
Or
what you guys said?
go to community college. There's like all kinds of community colleges that night classes, you know, that kind of stuff. I mean, you have to be pretty patient in maybe finding a course that's gonna, like I took the one, obviously we're local, so I took the course that was in like Upper Bucks County. And I mean, I had to drive pretty far every time. It was 2 days a week, and it was like almost a 45 to 50-minute drive for me to get there. And the course went until 10 o'clock at night, so I wasn't getting home until like 11:30. So that was like a 9-month course, 2 days a week, getting home like close to midnight, not like, you know, eating dinner in the car as I'm leaving work to get to it. But, you know, it definitely was incredibly helpful, and the best way is to just kind of like get some hands-on experience, and that's going to allow you. There's always the opportunity to be a button pusher at a manufacturer, which is going to allow you to understand probably like the setup aspect of how to run CNC machine, and like how to like measure your tools and set up your workpiece, and like maybe slightly interpret the G code, which would allow you to then go home and buy a machine and be like, I can do this without just like smashing the spindle straight down into the table. I didn't mean to do that. So yeah, that's what I would do. I would take a course. I'm not good at watching YouTube, and I'm not a millennial, so.
I got really lucky to have a mentor. So I was building bikes out of a local bike shop, and a guy walked in and saw what I was doing, and his name is Warren. He's a machinist, tool and die maker. He's got a little garage, not a garage, it's like a step up from a garage. It's an outbuilding prototype shop that he works out of. He saw what I was doing and saw the potential, and then just offered to teach me. So I got super lucky with that, and if you can find that, that would be awesome. But yeah, classes are another legit way. I learned a lot from video. I learned all my software from video, but I would be sort of hesitant to just rely on video only for actually running the machines. Anything else? We've got 15 minutes. Yes.
I know we have a lot of machines like manual and CNCs. How do you find such big machines all used?
Patience? I don't know. I mean, I get it in my head. I want to get something. I'm definitely going to find it. Like my most recent machine, I do take a little bit of a leap of faith, because I've bought machines that I didn't see run, but I can inspect the spindle, and I can inspect like the overall condition of a machine pretty quickly, and make this decision. My Okuma lathe, it's still available, new, and it's like, it doesn't have the same exterior, but from a standpoint of like, it's a boxway machine that has like a 30 horsepower spindle and like rapids that are just under 2,000 inches per minute. I mean, like all that stuff is still the same. It's just a little bit different aesthetically on the outside. And it's like a $125,000 machine baseline. So this is like $150,000. It had high pressure cooling, like a few other options. And I bought this machine for $11,000. And I bought it from the company that was done using it, and mainly the reason they were done using it was because it had a chip conveyor, and it probably ran 24/7 with the chip conveyor running, and they never, ever, ever shut it down to clean it. Because it had a chip conveyor. Why? Like, I'm not going to shut it down for a couple of days. It's not working. So it was filthy. And it was paid for because it was a 2005, and this is like, 2014. And more than likely, someone came and said, well, we can buy the new version, and it's going to make all of our parts this much faster. So we're going to take this one off the floor, and we're going to put this one on the floor, and we're going to employ this one, and it's going to make us just as much money or more than shutting this one down for a week and cleaning it. So let's just sell it. And they don't care about it. They don't care how much it's worth, because it's been depreciated, it's done, it's no longer an asset to them, and they just want it out of there. And you have to be ready to snatch it up. And so, for $11,000, I'm buying a machine that even on the used market is going to sell for 40, 50 grand.
So you're like a rare build.
I'm just patient. I'm telling you, I hunted for that machine for like 2 years.
Where did you look to find that? Where did you find these?
A lot of times it starts with insomnia. You know, you're just like up in the middle of the night, and you're just like, oh, I'm gonna look for machines. You know?
Is it eBay, Craigslist?
No, I don't bother with, like, definitely don't buy anything off of a dealer, and I don't buy anything off of eBay. I mean, there is a surplus company in Ohio called HGR that is like just all they do is flip equipment. And I've bought enough stuff from them that they have a person who sends me emails that, you know, like, oh, we have this thing, it hasn't gone on the floor yet, and it hasn't even left the facility yet. And these guys will sell you this for like $1,000 profit if they never need to touch it. So it's just like, oh, they probably bought that thing for like $6 grand from that company and sold it to me for 11 grand. You know, but I don't care that I made them $5,000 to literally pick up the phone. I saved a ton of money by buying it for $11,000. And the whole thing with that was, though, I bought it literally sight unseen. I had 4 pictures, and I was just like, I'm buying it. And I had 30 days to land it, power it up, and decide if I wanted to keep it. And if I didn't, I would only lose like $3,000, which would be the shipping to and from. So I went for it. I was like, I'm either going to save 20 grand or I'm going to lose 3. I'm in. So, but that's, you know, that's mostly how I acquire the stuff, is just finding it and being willing to take a leap of faith.
With all the cost of all the equipment you have and all the work you put into making your bikes unique, do you think it's not just money for you, but it's also just the craftsmanship that I put out a perfect bike?
Nothing's perfect.
But yours is as much as close to your.
It's as perfect as I can make it. Yeah, I don't know. I'm stubborn. I've been in this industry a very long time, and I have definitely like found what it is that I like and what I don't like about bicycles. And everything that I didn't like about bicycles, I decided at that point when I was going to make bikes that I was going to try and resolve every single one of those issues. You know, and the funny thing is, like, some of them have slightly gone away. You know, like when I first had my mountain bike drop out, I wanted my derailleur hanger to be removed from the bearing surface of the quick release skewer. But that drove me crazy that a dropout was like half the thickness, and the other half of the thickness was the hanger. And this is not like 1 or 2 bikes. It was like everybody. This was how it was done. You would make a derailleur hanger that was half the thickness of your dropout, and then you would like tighten your wheel, and you would watch the derailleur go like this or go like that. And half of that was because it wasn't well made, but the other half is because it was just not a good idea. And so I removed the derailleur hanger from that part of the equation, and I had my derailleur hanger is separately bolted onto the dropout and had no bearing surface on the skewer. But now with like the through axle designs, that kind of became a little bit of the norm, where you don't really have that same concept of like being half the thickness and being kind of weak. It was always a weak link on the scenario. And then the other thing that I wanted to do, like if you look at my mountain bike dropouts, here's the axle line, and then the chainstay is like 1.5 inches below the axle line. I purposely like wanted to angle it down and then go in essentially a parallel line to the ground to the bottom bracket. And the reasoning for that was that chain slap drove me crazy. I was like, oh, this is like the dumbest thing. But then clutch derailleurs came out, and it was just like, oh, all right, well, I did solve that problem, but it didn't need to be solved anymore because they came out with the clutch derailleur. And, you know, like a lot of those little things would just like really, really irk me. And I was like, well, I'm in a situation where everything that, like, all the little ins and outs of a bicycle that kind of bothered me when it came to being like a master mechanic end of things, I had the opportunity to tweak. And so I did. I try to make it look good along the way, but just about everything that I do is for a functional reason more than anything else.
Are there any manufacturing processes that you'd be interested to learn and to try out?
Are you more like 3D printing or?
Anything.
I mean, I like making anything. So, yeah, I'm definitely intrigued by 5-axis machining, but it's, I think that it's like all the rage for like unjust reasons right now. I think that it's a little bit of an ego thing that like, because I mean, I make some pretty complicated parts with a 3-axis machine. You know, it's just more setup. And so I think that the 5-axis machine definitely opens up a lot of opportunity, but I don't know if it opens up an opportunity of something that's not makeable in another way. So I do think that it's cool, and I would love to explore like the ability to do 5-axis, but I don't think it's going to make something that I can't currently make.
Yeah, I would love to explore 3D printing like I mentioned earlier, and I've seen some super cool like rotary laser engravers that I think would be very fun to play with. And then
Laser engraved.
yeah, and then this is kind of old school, but still a machine. I really want a rose engine, which does this. If you ever look at high quality watches, they have an enameled surface, and there's a pattern that they lay the enamel on. They use a machine called a rose engine for that. It's like super old school. It's not computer driven at all, but you can make some really beautiful, interesting textures with, and that's one of the things that I'm kind of like, I want to try that.
What parts do you want to use the rose engine for?
I'm not sure. Yeah,
Inlays.
Yeah, like something like inlays would be really cool. And I don't know if you can use. Actually, I have seen people do little vessels, and then they use the rose engine to texture the outside of the vessel. So kind of leveraging that in a fancy lug or something like that would be interesting.
Mike?
Yeah.
You said you use FEA. Do you still do physical testing then, or
Yeah,
is one replace
I don't do.
the other? Or?
So I don't do. A lot of the parts that I make are pretty overbuilt. So like once I do the FEA, I'll make like a couple versions of it, and I'll do some like, you know, crude. I don't make any parts that I do like literal cycle time testing. So I haven't done anything where I've done like, you know, 100,000 cycles or 1,000,000 cycles to see when it cracks. I will do like 1 or 2 and then just do some massive fatigue testing to see like how much leverage it took to snap this or break that. But I don't do any testing that does it in the thousands of cycles. Mostly, a lot of the stuff that we do, you have to bear in mind that because every bicycle is unique, you would literally have to make every single bike twice. Because you have to make the bike the first time, do all the cycle testing that you're talking about. And if it makes it to 200,000 cycles, if that was your goal, 2,000,000 cycles, whatever that cycle is, then you need to repeat that product exactly the same way. Otherwise, any testing that you did is a moot point. It's irrelevant. So like if I found out a way to cycle test one of my yokes, I would have to say like, well, okay, so was the yoke attached to the bottom bracket and then the change days were attached to it, but what was the drop of the bike? Because every time the drop change, what was the length of the change stays? What was this? What was that? All that stuff is going to have a different version of that cycle test. So you have to say to yourself, you're just like, I know that like this part is not pushing the boundaries in a way that I'm making anybody in the world unsafe. You know, like I don't make any parts that are going to push the boundary when it comes to being super duper light or super duper unsafe. You know, it's the FEA testing is really, in my opinion, like enough combined with my mechanical understanding and my experience in this industry to know whether or not a part is going to be sound or not sound.
Yeah, I agree with all that.
Do either one of you make parts to offset your, like, for other things or for other people, for income otherwise? Or?
Job shop stuff?
Like besides bicycle stuff?
Yeah, I guess. I mean, take on jobs just to supplement the income because the machine's standing still or whatever.
It's high on my list of goals.
Yeah.
It drives me crazy that my machines sit idle.
Yeah.
You know, it's very difficult for me to own the machines that I own and see them sit idle. But I've also quoted jobs and you lose it on 15 cents on the part or 5 cents on the part. You're just like, oh man, I just spent like, 5 hours quoting that job and I didn't get it. And I was already like pushing the limits of what I was willing to do anyway.
Yeah.
So from that standpoint, I think that I'm kind of just accepted that I'm not going to go there. But I did introduce a part that I sell in mass to anybody who wants to buy it, and that is the way that I'm now going to try and employ the machines, which is that I have the seat collar, and I'm going to have a new part that's coming out, and I have the spiders, and so like any of the titanium parts that I make, I only make for myself. But some of the tools I make, I would sell to other people, and like the aluminum seat collar and the aluminum spider and some of the other things that I can make pretty quickly and in pretty high quantities. I'm now going to try and sell just essentially to create like a more consistent stream of income.
Right.
That if I make 500 seat collars and there's like this trickle in of money, like $100 each day or $75 or $125 each day from that all year, then that's cool.
Yeah.
So I'm cool with sitting on the inventory if it's just like trickling in all year. So I want to try and build up that aspect of the business because I see the light, which is that I am not a prolific maker of bicycles. And, granted, most of the bikes are pretty expensive, but they also have a ridiculous amount of time into them. And a better way for me to make some money is to try and increase the small parts.
Sure.
Yeah, it's the same with me. I'm not really at the level where I could do jobs like that, first of all, but if and when I get there, I think it's a better use of my time to sort of focus on making those little products, stems, seat posts, little, things like that I can sell that doesn't cost as much of a bike, doesn't have that amount of time in it. And I get a lot of requests too for repair work, and I turn all those down for the same reason, which is it's just not where I want to put my time. I'd rather put my time doing the design work.
She could get paid to do design work for other people.
Yeah.
Probably good. Well, I think that's it. That's been our hour. So thanks everyone for coming. Appreciate the questions.
No last ones? We're good? All right.